All right, so for this video, we're going to be talking through section 1.1b. So I've got a couple of more terms for you and a few more examples. So we're going to start first with the term collinear. So before I open it up and read you the definition, I just want you to look at that word, collinear. So hopefully when you see the word linear, your eyes are drawn to line. And when you see the word co, it makes you think multiple. Together, something like that, collinear. So if points are collinear, it means that they lie on the same line. They're together on the same line. So here's an example of what that could look like. Here is a line. And if points on a line are collinear, they're on the same line. So an example of that would look like this. You could say that M, N, and O are collinear. Now, remember we talked about this in our last video. When you write points, you don't have to write anything in front of it. Just a capital letter means point. So M, N, and O, meaning points M, N, and O, are collinear. They're on the same line. So on the flip side of that, of course, we've got non-collinear. So that means that points are not on the same line. So an example of that for you could look something like this. I'm going to use those same three letters again. We could say M, N, and then if they're not all on the same line, meaning they're non-collinear, one of them needs to be not on the line. So I'm going to stick it right here. So between those 3 points, you cannot make one line. They're not all three on the same line. They are non-collinear. Okay, so M and N are collinear, but M, N, and O are non-collinear. All right. Coplanar, same thing. Co together, planar. Hopefully that makes you think of plane. So if points are coplanar, that means they are points that lie on the same plane. So here's an example. We talked about planes in our last video. I told you I was going to draw planes the best I could. So there's my attempt at a plane for today. If points are coplanar, it means they're on the same plane. So I can just put some points in here. X, Y, and Z. X, Y, and Z are coplanar. So then, of course, non-coplanar is going to mean the opposite of that. If points are non-coplanar, it means they don't lie on the same plane. So again, I'm going to start by drawing my plane. I can put X, Y, and Z back on my plane again. But this time, to make it non-coplanar, I've got to include our friend W out here. Okay, so for example, you could say W, X, and Z are non-coplanar. Okay, so X, Y, and Z are coplanar. They're all on the same plane, but as soon as you throw W into the mix, they're officially non-coplanar. They're not all on the same plane. I do have one example I want to look at today that is going to show you a couple of things you need to know. So here goes. So the first question on this one says, are points F, A, and Y coplanar or non-coplanar? So first let's identify those points. We've got point F, point A, and point Y. Are they coplanar or non-coplanar? This is where a lot of people get very bogged down. So I want you to think back to our last video. We were talking about what it means to make a plane, and we were talking about how to name a plane. And we said, if you'll remember, to name a plane, you need 3 points. Okay, and this is the part that I did not get to earlier. Your 3 points have to be non-collinear, meaning your 3 points cannot be on the same line. So anytime you have 3 points, F, A, and Y, and they don't form one line, which these do not, I cannot draw one line that goes through all 3 of those, then you can form a plane. So between F, A, and Y, there is a plane. Now, notice, but there's not a plane drawn on your paper that contains all 3 of those points, F, A, and Y. But remember, planes go on forever. They extend in every direction, and so that plane's just not drawn on your paper. But anytime I give you 3 points, and those 3 points do not form a line, then they are coplanar. So I'm going to box off coplanar, and my explanation is it can be any 3 non-collinear points form a plane. All right, look at the next one. Are F and Y collinear? Again, we're not going to get too bogged down on our picture. We're looking at F and Y, those 2 points. Are they collinear or non-collinear? Okay, so let's back up again to our last video. When we talked about lines, we said that you have to have 2 points to name a line. So if I give you point F and I give you point Y, can you make a line between those 2 points? Absolutely. Is that line drawn on here? No. I can draw it if that makes you feel better. There it is. Are F and Y collinear? Absolutely. Okay, and my explanation there is going to be the same as it was before. Any 2 points can form a line. All right, look at your next question. Are the points F, R, and B coplanar or non-coplanar? Sorry, my picture is getting a little bit overwhelmed. Here's F, R, and B. Are those 3 points coplanar or non-coplanar? So let's look back at our first question. We answered coplanar or non-coplanar, and our explanation was that any 3 non-collinear points can form a plane. Okay, well, I've got 3 points. Do those 3 points meet this part of that, though? Are they non-collinear? Remember, non-collinear means points that do not lie on the same line. So let's check that out. F, R, and B. They all lie on the same line. So since they are collinear, they are not able to form a plane. So I'm going to say that those are non-coplanar. And my reasoning there is going to be that the 3 points must be non-collinear. Okay, last question for that example. Are the points F, R, and B collinear or non-collinear? So we kind of just talked about this. F, R, and B, collinear, non-collinear, they all form this one line together. That makes them collinear. So my reasoning there is going to be those 3 points are all on the same line. All right, I'll be back for my next part of 1.1.